dawns. The early morning mist blankets the fields as the cattle begin their peaceful graze, converting
Mixing rendered animal fat with the ash from their fires, they unknowingly created the world's first soap.
Check the pressure on line 4. It seems to be running a little high.
Noted. I'll make the adjustment now.
Every day, billions of people around the world rely on a simple object that most of us rarely think about: soap. But behind every smooth, fragrant bar lies a complex story of chemistry, engineering, and massive industrial production. In this documentary, we journey inside one of the world's largest luxury soap factories to discover how raw materials, including animal fat, are transformed into the elegant bars we use every day. Modern soap production operates on an industrial scale. Giant stainless steel reactors, automated conveyor systems, and precision chemical controls ensure consistency and quality. But to understand how soap is made today, we first need to understand the science behind it. A chemical reaction discovered thousands of years ago. The earliest forms of soap date back nearly 5,000 years. Ancient civilizations discovered that mixing animal fat with wood ash, then heating it with water, produced a strange but useful substance capable of removing grease and dirt. This accidental discovery laid the foundation for the soap-making process we know today. Soap works because of a chemical reaction called saponification. In this process, fats or oils react with a strong alkaline substance, typically sodium hydroxide. The fat molecules break apart and reorganize into fatty acid salts, the building blocks of soap. These molecules have a unique structure. One end attracts water, while the other attaches to oil and dirt, allowing soap to lift grease and wash it away. One of the key ingredients in traditional soap production is tallow, a purified form of animal fat. Tallow contains long chains of fatty acids, ideal for producing hard, long-lasting soap bars. These fats are carefully collected, refined, and transported to factories to become the foundation of luxury soap. Before it can be used, raw animal fat must be purified. At specialized facilities, fat is heated and filtered to remove proteins, moisture, and impurities, producing stable tallow ready for industrial processing. Once purified, the tallow is transported to massive soap manufacturing plants. Thousands of tons of raw material are stored in heated tanks, ready for the next stage: industrial saponification, the chemical heart of soap production. Now the real transformation begins. Inside these enormous stainless steel reactors, the purified tallow enters the heart of the factory, the saponification system. This is where chemistry turns raw fat into actual soap on an industrial scale. The refined fat is pumped into a large heated reactor. Temperature control is critical here, because fats must remain in a liquid state for proper chemical reaction. Precision pumping systems ensure exact measurements. Consistency is essential for high-quality soap production. Next comes sodium hydroxide, also known as caustic soda. This strong alkaline solution is carefully measured and added to the reactor. The balance between fat and alkali must be extremely precise. Too much or too little can affect the final texture and performance of the soap. When fats react with sodium hydroxide, a chemical process called saponification occurs. The triglyceride molecules break apart, forming fatty acid salts, which are the actual soap molecules, and glycerin as a valuable byproduct. This reaction is controlled with continuous mixing to ensure uniform conversion. Steam jackets surrounding the reactor provide controlled heating. Maintaining the correct temperature speeds up the reaction while preventing damage to the ingredients. Large industrial mixing blades rotate slowly, ensuring even distribution of chemicals throughout the tank. As the reaction progresses, the mixture thickens. The soap begins to separate from the liquid phase, forming what is known as soap curd. This marks the successful completion of the saponification stage. The glycerin produced during the reaction is separated through controlled processing. Glycerin is a valuable compound used in cosmetics and pharmaceuticals, so factories often recover and refine it for additional industrial use. At this stage, the factory has produced a raw soap base. However, it is not yet finished. The next steps, drying, refining, and milling, will transform this material into smooth, luxury-quality soap bars. After saponification, the soap base still contains excess water. To create create a stable, long-lasting luxury bar, this moisture must be carefully removed. That process happens inside massive vacuum drying towers designed for precise industrial dehydration. The hot liquid soap is pumped into the top of the drying tower. Inside, controlled vacuum conditions lower the boiling point of water, allowing moisture to evaporate quickly without damaging the soap structure. The liquid soap is atomized into tiny droplets. By increasing the surface area, the factory ensures rapid and uniform drying. This engineering step is essential for producing consistent soap texture. Because the system operates under reduced pressure, water evaporates efficiently at lower temperatures. This protects the fatty acid structure and maintains the soap's quality, hardness, and performance. As drying completes, the soap transforms into small, uniform granules known as soap noodles. These noodles are the foundation of modern soap manufacturing. Their controlled size ensures smooth processing in the next stages. The freshly produced soap noodles are with moisture removed and structure stabilized. The soap material is now ready for the refining stage, where industrial rollers will transform it into a perfectly smooth luxury blend. Now the soap noodles move into the refining area. Here, mechanical engineering plays a critical role in improving texture, density, and overall quality. The goal is to create a smooth, uniform soap structure suitable for luxury branding. The soap noodles are fed into a triple roller milling machine. This powerful system uses 3 rotating steel rollers operating at different speeds. The pressure between the rollers compresses and refines the soap repeatedly. As the soap passes between the rollers, its particles are compressed and evenly distributed. This process